Now, in simplifying these, you could multiply out the top and get 24, and multiply out the bottom and get 6, and then do 24 divided by 6 and get an answer of 4 for this one. But you could also simplify it. You see the 3 divided by 3, those would cancel out. And those will all simplify to be 1s. So we could get 4 that way as well. In fact, that makes our math a little bit easier. Same thing in the second one, these 4s. Those would all simplify away, and we're just left with 6 times 5. The second one is going to be 30. And same thing in this last one. Those would all simplify away. Now we got a little bit of math to do. 8 times 7, 56. 56 times 6. 336. You will have to do some mental math multiplying things out like this. But when we get to the construct the understanding, there are 4 ferry routes from Vancouver area to Vancouver Island. You want to travel to Vancouver Island by one route and travel back using a different route or route. Okay. This is a fundamental counting principle. How many decisions do you have? 2 decisions. So we draw 2 spaces. If I describe my first decision is Vancouver to Vancouver Island. And then I have to decide how I'm getting back, Vancouver Island back to Vancouver. From Vancouver to Vancouver Island, how many choices do you have? 4. You can take any ferry route you'd like. But if you're coming back and using a different one, how many choices do you now have? 3. So there's going to be 12 in total. Okay. If a 5th route was Adam, do you see that this would be 5 and 4 and 20? If a 6th one would be 6 and 5 and 30. So what we have and what we're getting to, and I've showed this to you already before, the exclamation mark we're going to learn about. Take out your highlighter, we've got new definition. An arrangement of a set of objects. I'll highlight that whole thing. And the key thing that we're going to talk about quite a bit, if you're arranging things and the order matters, this is a permutation. So if you took the 7 letters of the word Kelowna and you wanted to rearrange them, how many different rearrangements could there be? Do you see that you would have 7 decisions to make? And the first letter could be any letter. How many choices would that be? 7. But let's say you picked a W for the first one. Then when you go to the second letter, you don't have 7 letters left anymore because you used up 1. How many choices do you have left? 6, then 5, then 4, then 3, then 2, then 1. And this happens often enough in counting that they have, I showed you this before, included a notation for this with an exclamation mark. Right? So 7 with an exclamation mark doesn't mean you yell it out. I mean, you can if you want to. 7! Be very excited. But it means 7 times 6 times 5 times 4 times 3 times 2 times 1. And if you multiplied all of those together, you get 5,040. That exclamation mark is called a factorial, and this is called factorial notation. A very excited 1 is just 1. A very excited 2, it lives next door to 1, is just 2. But 3 is 6. And 4 is already 24. And each time you're multiplying all the way down to 1. So if you had an n factorial, you'd start with n. Then you'd subtract 1. Then you'd subtract another one, subtracting, and you would keep going until you got to 3 times 2 times 1. For factorials, for us, it's only going to make sense, this part, if n is bigger than or equal to 1, and n has to belong to the natural numbers. We're only going to do whole numbers, because you can't go down by 1 and end at 1 if you started at anything else. And then this is a special case. And in order for some of the formulas to work, we have to define that 0 factorial is 1. Maybe because it lives close to 1 as well, just like 2. It's kind of boring. 0 factorial is equal to 1. Now that doesn't make sense with what it means to multiply down to 1. It's its own thing. So it's like, you have to know that anything factorial means multiply down to 1 except for 0. 0 factorial is a special case. It's equal to 1. And we'll see why this happens. So if you have 10 things, you want to arrange them in a row where the order matters, the answer is going to be 10 factorial if all 10 are different. You should find the exclamation button on your calculator. So take a moment. Take out your calculator that you're going to use on your exam, your scientific calculator. Take out your graphing calculator, you're going to use it for this test. So start to think about which calculator you're going to use for the exam, because you can't use your graphing calculator. And make sure you know where the log buttons are, the exclamation buttons are, how to change from degrees to radians. So see if you can find the exclamation mark. For the graphing calculator, it's kind of a little bit tricky. I'll show you where it is. Maybe. There we go. Oh. There we go. All good. Couple of different things. You can go hit the math button and actually have to go all the way over to probability. And there it is, number 4. If you have a newer calculator that has the menus, you can go alpha F2, and there it is at number 9. I better not do that number. I might be able to do 5 factorial. 120. So we need to know where the factorial button is on our calculator as well. And with that, we can do question number 1. A puzzle designer decides to scramble all the letters of the word education. How many 9-letter permutations are possible? So there's 9 different objects. 1, 2, 3, 4, 5, 6, 7. We could do this as spaces. And then you can pick any letter to be first, so you would have 9 choices. But once you've used a letter up, it's gone. And then you look how many letters are left for the second decision. 8 choices left. Then 7, then 6, then 5, then 4, then 3, then 2, then 1. Which this would be a lot quicker if we could just write it like this, 9 factorial. You know what's really cool about the word education? English language has 5 vowels. Education has all 5 vowels. So I'm going to give you a puzzle. What is the shortest English word you can think of that has all 5 vowels? And I will tell you, you can't use, there is a 1-cell organism that somebody named, I don't know how it, but they just used all 5 vowels and made some word. I don't know how it's pronounced. But we're not going to count that one. I know of a English word. See if you can, it's a puzzle. I'm giving you this puzzle. English word 6 letters long that has all 5 vowels in it. You got a guess already?
Do we have to use a Y?
No, don't have to use the Y. Because it's only sometimes a vowel in English.
Is it education?
Education has 9. There's one that has 6 letters. And I'll give you a hint. But then I won't tell you for what. Because you're not going to pay attention to the next 5 minutes of class now that I've given you this puzzle. Great. It's a good strategy, good teaching strategy. There is a vehicle that has this name. It is also the name of a tree. So you have to know your kinds of trees. Okay. Oh. Now you won't be able to pay. I'll give you your questions. 3, 5, and 9. You got to know your trees. Okay. And if that puzzle is giving you a headache, I'll give you another puzzle. Okay. Here's another puzzle. What is an English word that starts with the letters HE, ends with the letters HE, but isn't he or he or any of those? I think of an English word that has HE at the start, starts with he, ends with he, and for that one, what makes it worse is I said the word in the last minute. So you can watch the video and figure it out.
Earth?
No, it doesn't have anything, just the TH. Okay, so now I'm giving you 2 puzzles.
Bro. I see the tree over there.